two key rules that you need to know about multiplying. First one is when you're multiplying and the radicands are different. Second one is when you're multiplying and the radicands are the same. Jack, where you been? Multiplying when the radicands are different is coefficient times coefficient, radicand times radicand. Coefficient times coefficient, radicand times radicand. So we would take a times b and make it ab. And then we would take root of x times root of y and make it root of xy. Coefficient times coefficient, radicand times radicand. If the radicands are the same, we have a different rule. So what is x times x? So in theory, this should be the root of x squared. But what's the root of x squared?
X.
X. So root of x times root of x just equals x. Root of x times root of x just equals x. When multiplying coefficient times coefficient, do you hear like a band, like band noise? That's really weird. But I hear like brass.
Yeah, I do. What?
Like brass instruments. No, I hear like...
I did hear the brass for a second. I did.
Coefficient times coefficient, radicand times radicand. Which is almost the same as polynomials where we do coefficient times coefficient, variable times variable. Same idea. And just like polynomials, the last step is always simplify if necessary. Simplify if necessary. Put away. Put away. Put it away. Put it away. So you do coefficients together, and then root of x times root of x would be x. So it would be whatever the coefficient is times x. Like an example we're about to do. Okay, let's look at some examples. I'm assuming you already have your title? Yes.
Yeah, I guess.
Thank you for humoring me. Thank you, thank you. Well, the dividing is actually called rationalizing, which we'll talk about in a second. This is just like polynomials where we have a monomial outside and a binomial in the brackets. This is where we do distribution. Please tell me that looks familiar. Very good. What's the coefficient in front of this root 3 that we don't see, but we know it's there? So I'm just going to put it in just for this example so you see what we're multiplying. So I'm going to multiply the first term by the monomial. So I do 2 times 1, so coefficient times coefficient. 2 times 1 is 2. Then radicand times radicand, root 5 times root 3 is root 15. Coefficient times coefficient, radicand times radicand. Then I'm going to do the same with the back term. So 2 times negative 4, negative 8. 5 times 10, so I get negative 8 root 50. Then we just need to know, can we simplify?
Yeah.
15. Any perfect square factor or perfect square factors hiding in 15?
No.
What about 50?
25.
25 times? 2. And then we break 25 into? Almost 5 squared. So this is just what you did on Friday and what we did yesterday with the adding, subtracting. So the 2 root 15 is going to stay. The negative 8 is going to stay for now. And I'm just going to change root 50 into 5 squared times 2. The 5 squared is going to come outside, and what's going to happen to that squared? It's going to disappear. So I still have my 2 root 15. When the 5 comes out and the squared disappears, I've already got an 8 there, so what do I do with the 8 and the 5? Multiply. So 8 times 5. And root 2. Can I combine these? Can I add and subtract these like yesterday? Why not?
They're different.
Different radicands. Done. That's multiplying radicals. Number 2, binomial times binomial. I'm going to show you the 2 different ways that I do binomials, and you can pick whichever way you like better. You might have seen these in grade 10, you might not. They might be old, they might be new, whatever. So probably the first one you've heard FOIL, right, which is double distribution. So you can either do it with the arrows or you can write out the letters, whatever makes sense. I'll do letters first. Yeah, absolutely. So first times first would be our 2 root 3 times root 3. Our outside would be our 2 root 3 times negative root 2. Inside would be 3 root 2 times root 3. And our last would be our 3 root 2 times negative root 2. Do you have to list that out? Nope. Just showing you step by step for the first one. Coefficient times coefficient, radicand times radicand. So 2 times imaginary 1. Root 3 times itself. Be careful here. What's a root times itself? The root pops out, because what you're doing here really is square root of 9, and what's the square root of 9? 3. So I've got a 2 times a 3, and I'm just going to simplify those up. What's 2 times 3? 6. So first term comes out to be 6. 2 times negative 1, negative 2. Root 3 times root 2, root 6. 3 times imaginary 1. Root 2 times root 6, or root 3. Ooh, I told you the answer. 3 times imaginary 1, negative 1. 3 times imaginary, negative 1. Negative 3. Be careful, root 2 times itself, root of 4, but then that becomes 2, and then I'm just going to simplify negative 3 times 2, negative 6. Now I'm just going to put all those together. So I have a 6, I have a negative 2 root 6, a positive 3 root 6, and a negative 6.
12 root 6.
So when we combine, we're going to do the whole numbers first. So 6 minus 6. And I'm just going to write it just so you see later what happened to the 6 and minus 6. We wouldn't normally write it. And then are these like radicals? Yes. So if I have negative 2 of something and 3 of something, how many somethings do I have? So the final answer is just root of 6. How crazy is we can take all this stuff and multiply and it all comes down to that? You do not need to write it out like this. If you like the arrows, a lot of people do, that's fine. I'm going to show you a totally different way to do it. If you like it better, great. I'm going to create what's called a tic-tac-toe board. I'm assuming you've seen that before.
Oh, yeah.
2 vertical lines, 2 horizontal lines. No, it just works different for different brains. I'm going to put a multiplication sign in the top left corner. I'm going to take the first binomial and write it along the top. So a 2 root 3 in the first box, and then the 3 root 2 in the second box. And I'm going to take the second binomial and write it down the side, so root 3 in the first box, and then negative root 2 in the second box. Then I like to switch colors because it's how my brain works. And all I'm going to do is multiply where the boxes intersect. So my first one is 2 root 3 times root 3. So 2 times imaginary 1 is 2. Root 3 times root 3 is just positive 3. Next box to the side is 3 times imaginary 1 is 3. Root 2 times root 3 is root 6. The bottom box is 2 times imaginary negative 1, so negative 2. Root 3 times root 2 is root 6. And the last one is 3 times negative 1, so negative 3. And root 2 times root 2 is 2. Then I'm just going to simplify it up, so 3 times 2 is 6. I have positive 3 root 6, minus 2 root 6, and minus 6. And if you'll notice here, we've got the exact same step. It's just how we got there was different. And so eventually it's going to simplify up to be root of 6. Whatever way your brain likes better, I don't care how you do it as long as you get the answer correct. Number 3. How do we multiply when we have a binomial squared? So I'm going to show you the wrong way to do this. Some people like to have that in their notes. Some people do not like to have wrong methods. It's completely up to you. But I'm going to tell you a common mistake that someone is going to do on the final exam. People like to take this and distribute. And so root of 3 squared is 3, and root of 6 squared is 6. So therefore, the answer has to be 9. Because somebody does it all the time.
But it's the whole thing.
I know. And we can't distribute an exponent when this is a binomial. There's no exponent law that deals with a plus b. So how do we do this? We just write it out twice, and it just becomes FOIL or tic-tac-toe. Okay, so you can't distribute an exponent. It doesn't work like a coefficient in the front. Pick whichever method you like and multiply these two binomials. I'm going to do this one with the arrows, so showing you a third way to do it. So root 3 times root 3 is 3. Root 3 times root 6 is plus root 18. Root 6 times root 3 is another root 18. And root 6 times itself is plus 6. Then I'm going to combine the two numbers. 3 plus 6 is 9. And then I have 1 root 18 plus another root 18 has to be 2 root 18. So whatever method you did, you should be with me now at that step.
Well, wait, I thought when doing FOIL you would get the 9 and the 36 initially. Because it would...
This isn't FOIL. This is called double distribution. So a third method how to do it. Now we just need to look, what about sneaky number 18? What's hidden in 18? So we got to simplify him. We're going to break them up into 3 squared times 2. The 9's just going to stay in front. When I bring the 3 squared out front, what happens to the squared? Cancel, so now I have 2 times 3. 6 plus root 2. If you didn't see the simplifying, that's okay, we're still practicing, but could you get to the 9 plus 2 root 18? That's the important part. Could you get there on your own? How are we feeling? Good. Last example is just going to mix it up. Instead of numbers as radicans, we're going to throw in some variables, because who doesn't love variables? No, they're kind of cute. They're kind of cute. Look at them. They're very cute. Pick any method you want. I'm going to do tic-tac-toe just because why not?
They're like the Vanessa of the numerical world. Are you kidding me? No, I'm not. This is legit Tasha right here.
So before simplifying, however you got there, these should be your 4 terms. Any questions where any of those came from? Cameron's making the face. The what face? The what? Okay.
Why should we take off the root size with 2x?
Root of x times root of x is x. So you get root of x squared, which then becomes x. So all I can combine with this one is the radical, so I'm just going to leave my 2x. I'm going to keep my negative 3y. It doesn't matter if they're the first terms, the last terms, it doesn't matter. I'm just putting them first. And then I'm going to have 1 root of xy. So the order is irrelevant as long as those are your 3 final terms. Anything you don't see, anything you're not sure why I put that down, what's going on? I'll just ask you again, we can stop now and do the multiplying homework and then tomorrow do the last part, or do you want to go on with the notes and have all of tomorrow to work? To which of those opposing options? You want to keep going? We're going to do the equivalent of dividing, which is actually called rationalizing, which makes it sound so fancy. So I'm just going to put dividing in brackets. It's called rationalizing. Here's the truth. Mathematicians are fussy people. There's certain things we like exactly the way they should be, and there's some things we don't care about. This is one of the things that we really, really, really care about. We just cannot stand when a question has a radical in the denominator. Like, it seriously gives me the heebie-jeebies to look at. I can't even look at the questions right now. If there's a radical in the bottom, it just bugs us to no end. So what we have to do is get rid, I don't know, we don't know why. It just doesn't look right. It just doesn't. It's like, you know, when someone's typing and they don't put any punctuation in any capitals? You know how it just looks wrong? Same thing here. It just look, you can't, oh, if there's no punctuation, it drives me crazy. Ooh, can't do it. Imagine if like the entire book you're reading in English had no capitals and no punctuation.
I'd probably be okay.
Left brain. So we're going to do something called rationalizing, and the sole purpose is to get rid of the root on the bottom. It's called rationalizing, and it's just to get rid of the root on the bottom. Top is fine. We don't care about that. It's this root on the bottom. Like this, the fact there's a root 3, oh, like drives me crazy. This one, I don't care there's a root 3 on the top, but I care about that root 5 on the bottom. So I split the examples. 1 and 2 for this is when there's a monomial on the bottom, and this one is when there's a binomial on the bottom. So we're going to look at them two separately. First box, to rationalize a radical expression. Multiply the top and bottom by the radical in the bottom.
That radical is its own demise. I tried to think of something better.
So let's move to paper, and I'll tell you why we multiply by the radical in the top and bottom. This right here, to a mathematician, this is irritating.
I did it
It does. Just, ugh. It's kind of like to a mathematician as you would never write this. That's multiplication. What would you write it as? X squared. We would just never write x times x because we have an easier way to do it. I would never leave something with x plus x. What would I write that as? There's just things in math we just don't do. We don't do this. We don't put a radical in the bottom. So rationalizing is the process of getting rid of that radical. What I'm going to do is multiply the top and the bottom by the exact same radical. I'm going to multiply the top and the bottom by the exact same radical. Now let's stop and talk mathematically. Why can I do that? Because we can't just take an expression and just multiply by whatever we want. What is the only number in the world that when you multiply it, it doesn't change the original number? What's the only number in the world that when you multiply it by, the original number does not change? So 7 times what still gives you 7? 9 times what still gives you 9? 20 times 20 still gives you what? So the only thing we're allowed to multiply in math is by 1. You can multiply by 1 in every equation, every step in an equation. You can do that whenever you feel like it. We can't multiply by 2 or multiply by 0 because that's changing the original number. Well, take a look at this. If I were to reduce it, what is it equal to? It's equal to 1. And that's why I'm allowed to do it. It's because I'm just really multiplying by 1. And we know mathematically that doesn't change anything. I could not multiply this by anything else except something equal to 1. Now this is a fraction times a fraction, so let's just review grade 9. How do we multiply a fraction times a fraction? If you say common denominator, I may explode. How do we multiply a fraction? Top times top, bottom times bottom. So top times top, bottom times bottom. 6 times root 3, this is why we just did multiplication. What's 6 times root 3? And on the bottom I have root 3 times itself, which looks like root 9, but then we know root 9 becomes? And then I just need to simplify, and all I can simplify in this case is the whole numbers. I can't simplify a radical over a whole number. All I can do is reduce 6 on 3. What is 6 on 3 equal to? Grab your calculators. I want you to find me the decimal value of the question 1 divided by root of 3. Find me the decimal equivalent of 1 divided by root 3. When someone has it, shout it out. 6, or 6 divided by root 3. On your calculator, 6 divided by root 3. Give it all, 3.4. And that sounds confirmed? Give me the value, decimal equivalent of 2 times root 3. Or 2 root 3. I have not changed the value. All I've changed is what it looks like. Why? Because we just don't like the root in the bottom. This is unsimplified, unrationalized. This is rationalized or simplified. I have not changed its value. I just changed what it looks like. Why? We don't know. We just don't like it. You still with me? Let's do another one with a monomial on the bottom. 2 root 3 divided by 3 root 5. I'm going to multiply by the radical in the bottom, so I'm not going to multiply by this 3. He's not a radical, he's a coefficient. So I'm just going to multiply by radical 5 over radical 5. So just making a note, don't include coefficient. You can, but it's going to make more work for you. If you were to multiply by 3 root 5 over 3 root 5, it just means you'd have more simplifying at the end. So we don't, because there's no point. What is root 5 over root 5 equal to? And that's the only reason I can do this is because I'm multiplying by 1, and multiplying by 1 isn't going to change anything. Top times top, bottom times bottom. Coefficient times coefficient, so 2 times imaginary 1. Root 3 times root 5. On the bottom, 3 times imaginary 1. Root 5 times itself. And the last step, I'm just going to simplify up the bottom. What is 3 times 5? You cannot cancel a radical with a coefficient or a whole number. You cannot simplify root 15 over 15. So just make yourself a note. No simplify. You can simplify coefficients. You can simplify a radical with a radical. You cannot simplify a radical with a whole number. So what's our final answer? This is it. 2 root 15 over 15. And if on our calc we were to put in our original question and this new answer, they're the exact same value. They just look different. That's all. Questions so far? Well, what if the bottom's a binomial? No crying in math class. You have not cried once this semester so far. Nice. When the denominator is a binomial, we're going to multiply the top and the bottom by what's called the conjugate binomial. This is going to come back to you in grade 12, in grade or calculus. If you take IB math, this conjugate binomial is going to come back over and over and over. The definition of a conjugate binomial is the exact same terms, but the sign in the middle is opposite. If you're a wordy person, exact same terms, opposite middle sign. So if I gave you or I want the conjugate of A plus B, I'm going to keep the A. I'm going to keep the B. What's going to go in the middle? A minus. That's called the conjugate binomial. And I'll show you with the first example why it works. So if it's just a monomial, no big deal. We just multiply by the same radical. If we're down here, then we have to use what's called the conjugate. So let's look at number 3 with that binomial on the bottom. 2 over root 5 minus root 2. So I'm going to multiply the top by the conjugate and the bottom by the conjugate. In order to get a conjugate, I take the same terms. What do I do with this negative that's in the original question? Change it to a positive. That's called the conjugate binomial. Why mathematically can I multiply by all of this? Because it's equals 1. That's why you have to put a plus on the top and bottom. You can't put a negative on the top. You can't put a negative on the bottom. It has to be the 2 pluses because it's the conjugate. Still with me? I'm going to bracket the binomials because my brain needs the brackets to know that I'm going to be foiling on the bottom. If your brain doesn't need the brackets, don't feel you need to. So the top, I'm going to do 2 times root 5, and then I'm going to do 2 times root 2. Agree? 2 root 5 plus 2 root 2. On the bottom, I can tic-tac-toe, I can FOIL, I can double distribute, whatever you want. I'm going to do FOIL, and I'm going to do it the short way. Root 5 times itself.
5.
Now I'm going to the outside. Root 5 times root 2. Now I'm going to the inside. Negative root 2 times root 5. And the last, negative root 2 times itself. Whoa, we're not supposed to have roots on the bottom. That's what the conjugate binomial do. It's the only way to make them cancel. If you've done your binomial or conjugate binomial correctly, those will always cancel. It's the only way to get rid of the roots on the bottom. There is nothing else I can multiply by and get rid of these on the bottom. So let's just simplify. Top is as is. The bottom, I just need to combine that 5 and negative 2. Just smush them together. It gives me 3. Final answer. Again, if I were to put the original question in my calculator and I were to put this in the calculator, they're the exact same value. I've just changed what it looks like. The only way to get rid of it on the bottom when it's a binomial is this conjugate. The only way to multiply by something is to make the conjugate on the top and the bottom because it's equal to 1. Last one. This is as hard as they're going to get. I'm going to start again by showing you the wrong way to do this question, and someone is going to do it. That's why I like to point it out. So I will show you, and then you will tell me why it is wrong. But no, you said conjugate binomial. I did conjugate binomial. What? No, I did. I changed the sign. What? What? It's still a binomial.
You changed both the radicals. That's close there.
Did I multiply by 1?
No.
No, and that's what's going to happen is people are going to take the conjugate of both of these. It's only the conjugate of the bottom, so this still has to be the plus up there. Okay, so whatever you take the conjugate of binomial, that's also what's got to be on the top. This has to be equal to 1. Again, I like to bracket because it's how my brain sees binomials. If you don't need the brackets, don't feel like you need to bracket. It's completely up to you.
If you did it the wrong way, you'd get 1, right? As an answer.
Say that again, if I did what the wrong way?
If you did what you were, like without a minus, you'd get 1.
Yes, but I would still have a root on the bottom, and then it's going to cancel, and it's not good. Okay, top times top first. So root 2 times root 2. Root 2 times root 1. I don't know why I put the roots there. Let's fix that. No roots here, just the ones. That's better. So we're at root 2 times 1, root 2. 1 times root 2. And then 1 times 1. Just pause there, make sure you know where all those pieces came from. On the bottom, 2 times root 2. To root 2 times 1. Negative 1 times root 2. And negative 1 times 1. If those roots on the bottom do not cancel, you have done something wrong, because that's the whole purpose of the binomial. Simplifying the top, I've got some numbers, so my 2 plus my 1 would give me. And then I got 1 root 2 and another root 2. How many root 2's do I have? And then the bottom, those canceled, so I just have my 2 minus 1. Do I need to write that 1 on the bottom? No, I can just write it as 3 plus 2 root 2. Like, doesn't that look a little nicer than that? This is nice. That, not so much. That's it. We'll quickly review at the beginning of tomorrow's class, and then you'll have the whole class just to work on the homework. So it means nothing.